Let's look at how do I implement a big data or a data lake solution. What do we need to implement that big data solution? Well, the premises remain same. The steps are more or less same way if you want to implement a data warehouse solution or a data lake. By and large, the principles are same. You extract data, you load the data, and then you visualize the data. So those principles are remaining the same. But the basic difference between data warehouse and data lake is you don't choose what to load in a data lake. In data lake, you just keep dumping data, and that's basically the difference. You don't need to differentiate or choose what to load in a typical data lake. You just keep storing it, and there's a danger there that typically you might create something which is what we call data swamps, where typically you store data which is not needed, and that there is redundancy that can build in. But that's fine, because typically from a data lake point of view, you use inexpensive data storage, and so from that perspective, I think it still be fine. Now, how do I implement a data lake? There are two possibilities. One is on premises as well as the second is on cloud. Different solutions, different softwares available for both the purposes. Let's look at cloud, because that's getting more popular now. On cloud, there are solutions available from Amazon Web Services or Microsoft Azure or from IBM, even from Oracle. But if you look at on-premises, there are solutions available from MapR, Hortonworks, Cloudera. They are ones which are popular. Both are absolutely fine. Now, which one to choose, whether to go on-premises or on cloud? Well, the choice is absolutely yours, because there are some customers who are not comfortable going on the cloud way from a security point of view, but both will work absolutely fine. We have seen that the cloud is getting more momentum, more acceptance. Simple reason is scalability. In cloud, the data storage, the kind of adaptability, kind of scalability that you can have is slightly higher as compared to what you can perhaps look at from an on-premises point of view. Now, the other solutions are the tools which are required to implement a typical data lake solution. You need data to be ingested, which basically means that in simple form, how do I get data, how do I extract data and then store it into my data lake. That data ingestion process, if you have structured data to be ingested, you need a tool something like Scoop. If you have a streaming data, you need something like Kafka. If you have some logs data, you need a different tool. So there are various tools which are available from a data ingestion point of view. Then once you have the data in your data lake, how do I visualize data? The normal tools, the visualization tool that you have, for example, Pentaho, or if you look at typical ClickView or Tableau, all the tools will work absolutely fine. So those are tools remain same, but then the basic difference is the architecture in which the data is stored, and the data basically gets accumulated. You don't need a data model, for example. In data warehouse, you need a data model. That's a must. But in data lake, you don't need a data lake. You don't need a data model, rather. You basically keep storing data, and that's it. That's where the difference is. The volume, variety, and velocity. These are the 3 V's of a typical data lake implementation. So which basically means that you keep storing data at a pace, variety of data, and that's the characteristics of a typical data lake implementation. If you ask me, real power of data lake will come if you look at hundreds of terabytes, and that's where the real crux of data lake or big data implementation is. More data that you have, the processing power of a typical data lake implementation is put to the use, to the best of its use. It's basically meant for handling large chunks of data, and that's where that differentiation comes in, and that's where that technology will play useful to you. The applications of big data or data lake are typically where you want to churn large data, you want to process large structured and unstructured data. So obviously a telecom or retail are the right candidates of verticals where a typical data lake or big data implementation will be absolutely useful. We have seen that large clients in this space are going for or already have implemented a big data solution which basically help them to handle the large data sets that is involved because the kind of business that they are involved in. A telecom, for example, a call data, huge amount of data they need to process, and the analytics that they need has to run across that large data set. So you have to have a data lake for that kind of purpose. So telecom is the right candidate vertical which is basically can absolutely get benefited from a big data or a data lake implementation. Retail, for example, the same thing. We have seen customers, for example, one of the customers that we have in the NBFC space, they are looking at data lake implementation from a data consolidation across all their enterprises. They have different businesses. They want to create a one repository which will basically get data from all their group companies, and that will basically act as a single information store or single data store for all their group companies. So those kind of applications are the ones which are right candidates of a typical data lake and big data implementations.